So a polynomial was prime if we couldn't factor it with rational numbers. And a polynomial is irreducible if we can't factor it with real numbers. Here's an example of an irreducible polynomial. How can we know for sure that this is irreducible? Well, let's try completing the square. So I've got x squared minus 6x, and I'm just going to make a little space and put the plus 10. Then off to the side, I'm going to draw a square. I've got an x squared, and then my negative 6x I split in half as two negative 3x's. So x times x, and then I need negative 3's here. To complete the square, I need a 9. Well, I can rewrite my 10 as 9 plus 1. 10 is the same as 9 plus 1, so I can replace that. But then this bit is a perfect square. It's x minus 3 squared plus 1. Why does that help me? Well, here I'm squaring a real number, so this is always positive, or 0. When I add 1 to it, I get something that's going to always be greater than or equal to 1. So this polynomial has no real zeros. It's always greater than or equal to 1, so it's never 0. No real numbers that are zeros means no factors that have real coefficients. It does have two perfectly good zeros, though. We'll set that equal to 0. Since I already completed the square, I'm going to use that to solve this, right? If x minus 3 squared plus 1 is 0, that means x minus 3 squared must be negative 1. So x minus 3 has to be one of the square roots of negative 1. That is, it has to be positive or negative I. So x is, adding 3 to both sides, 3 plus or minus I. Our two perfectly good roots are 3 plus I and 3 minus I. If we allow complex number coefficients, we can factor this polynomial as x minus 3 plus I times x minus 3 minus I. No problem. Okay. So we have a word for a polynomial that we can't factor using rational coefficients. We call that prime. But we saw in the last video that some prime polynomials can be factored if you let the coefficients be irrational. We call a polynomial that we can't factor with real coefficients irreducible. But now we saw in this video that some irreducible polynomials can be factored with complex coefficients. Okay, what about polynomials that can't be factored even with complex coefficients? What are they called? Well, it turns out they aren't called anything because there's no such thing. And that's what we're going to talk about in the next video.